Okay, now we are to the last three catalogs of the applications of different helical gearboxes. So this is the oldest series and very rarely used. There are particular applications for this. As you can see, Greaves, this catalog itself shows how is old it is. Greaves was the name in the 60s, 70s, and 80s. So Greaves Cotton Limited developed this model. This is basically a bevel gearbox. It's not a bevel helical. Bevel helical are two stage. So that is B2. Cooling tower were B series and ABM series. So B114. So single stage was it. But this is a single bevel gearbox. Basically, it's just a bevel pair inside. Okay. That's the certification and all. That's the technicalities. This size and this product is very interesting and it is very rarely used. It's very particular application and we don't have much competition in this. The only competition is the RAN series of Bonfigli, but that we only have the models which start from 140 size, not below that. RAN series is from smaller size also. Okay, so 140 size we have. So particularly in this, let me show you some images that will make it more clear. See, this way, like motor mounting, bevel gearbox, solid input. This is the Bonfigli model. Okay, this is like that. You can use two bevel gearboxes, output vertical upward, and you can connect using as another bevel gearbox with double output. So it is basically these two can be even worm gearboxes. Okay, like a screw jack. So this application is such that you have such platform and this four bevel gearboxes and these two along with this. So total how many bevel gearboxes we have used here? It's around seven and one motor. So that seven gearboxes, when the motor will lift the platform and bring it down, it will become an automatic mechanism. So it is basically used for lifting the platform and lifting the table. It is used in some applications like mainly where we supply. It is in the sanitary ware industry, when the uh, sinks and commodes and everything needs to be removed from their mold once they are ready. So this is in that's a whole line of this type of tables, turntables and lifting tables. Then screw jacks. So this type of lifting application, screw are inbuilt. So that is all in the application of uh, shredder machine also. So shredding machine may need that top lid to be lifted using such screw jack. And then we can also see this in a blow molding application and blow molding machines in which the extrusion takes place. There are more than three extruders. So you will learn about extruders today. So in that it will be more clear. So these all bevel gearboxes are there, and these bevel gearboxes have a particular models and selection catalog which we follow. So this is the drawings, dimensions, and applications and the ratios. So ratio 1 is to 1, yes, 1 is to 1 ratio is available. As you can see at 1500 RPM, it's 50 kilowatt. So if any inquiry is there of 5 HP, 10 HP, then I'm sorry, we can't provide. But if it's an inquiry of around 30 HP or 40 HP, then we can provide. So if 40 HP till it goes on till maybe like a 2000 HP. Okay, so it's a big range. So from 1 is to 1 to 5 is to 1. In 5 is to 1, you can see the capacity reduces almost to 16 kilowatts. So in higher ratio, you can give this. Okay. So that is it. Greaves Gears, premium transmission product number, Bevel gearbox. I showed you the applications as well. Okay, so these were the applications, lifting table mainly. Let me just close that part. Okay. Now this is the another application. This application is known as the aerator. Aerator. What is an aerator? Aerator is mainly used for aeration. Aeration is a part of an effluent plant, treatment plant, in which they need to maintain or increase the oxygen content, or what the word they use is to increase the amount of oxygen inside the um, water. So the water which is used in plants like chemical plants and power plants, steel industry, in the cement plants, that chemical oxygen demand COD is to be maintained. So the COD to maintain, they need to infuse the biological oxygen. So what do? They keep on churning the water. Okay, so that churning will create an oxygen content which from the air goes inside and increases the content of oxygen in the water. So this water is dead once it is used. So what do? They keep on churning it and it creates an increased level of oxygen and it makes it a fresher water to be used again for purpose of water treatment. Uh, use in the plant. Okay, so that is called aeration. So as you can see, this is like a big premise in which water, the polluted water comes from the dyes and chemicals and organics and pharma and textiles and whatever industry, and then they do aeration here. Okay, so treatment of it. So in that, such gearboxes with, you can see, bigger blades are mounted and which motorized, and in here the output, they rotate, so that creates a lot of speed, because of which the water will get churned and it will increase the oxygen content inside, because the air pushes the oxygen inside, so that the motor will be mounted on the top, and the output coupling here, the output shaft, this coupling will be coupled with the rotor. Okay, so these are all aerator gearboxes. So this, our model will look like this. This is our model, premium model. This is our model. This is some competitors model. In this center it is located mainly. Okay, so this is known as aerator gearbox. So aerator gearbox, we basically, if you understand, it is just a parallel helical gearbox with input bell housing, output solid shaft with an extra thrust bearing housing. So this is basically a VH3M, vertical parallel helical three-stage motorized input bell housing gearbox. So VH3M 200 model, it will be known as GA200, that is Greaves Aerator 200 series. So it is actually VH3M 200, but VH3M has a design like this, that is the same body as per helical catalog which you studied earlier. In this catalog only, when this gearbox is laid vertical, it becomes VH3M. Let me show you again that image. It will be much more clear. Yeah. So here, as you can see, this is VH. This is H3M. So instead of H3M, it is vertical. So it is VH3M. But it doesn't have the same body structure. So that what they did a product called Aerator series, GA series. So it is a special three hole. So one hole, two hole, and the third hole is in the backside. So in these three holes, there are three rods, and this gearbox stays in the air. Output shaft is vertical downward. This inquiry was very recent. So let me show you on my WhatsApp. Maybe I can find. Let it open. Let me go for another diagram of it. Okay, so this is the aerator gearbox. So selection is pretty much simple. As you go in the catalog, it's the same thing. Here all the load calculations are given, whatever you need, that is the mechanical capacities from 112 model to 250 model. Each of them have ratio from 25 to 42 normally that is used, and this is the capacities. Thermal capacities are also given. No need of fan. These are all low speed. Grade of oil is given, the quantity of oil, weight of the gearbox, the pretty much dimensions of all the parts. As you can see, this is a coupling in the input where the motor will be directly mounted. Adapter flange while housing, they call it. This is the rigid coupling on the output side on this output shaft. So here you have the adapter, here you have the dipstick and the indicator which will show you the level of oil. Okay, this is the top view. As you can see, there will be three holes for mounting. Okay, so this is a very new design. So GA112 to GA250, that is the series, and this is the part list. You can see the parts. Okay, so this is basically the Aerator series. Here also safety factor we take around 2 plus. If I can show you some image I have, I can show you that. That will be very useful. It was just an inquiry yesterday for the same. If you can see, and the inquiry, so let's just have a view of that. See, this is the aeration, this is the gearbox where it is located, this is the mounting. See, it is mounted on bolts, one bolt, second bolt, third bolt, and it is on air. The motor is on air, the gearbox shaft is directly mount. Okay, so this is the design. And that as the disc side where the gearbox shaft is fitted is on this side. This is the knee at the bottom where the rotors will be there. Okay, there's the rotor. I wanted you to see this image because this image shows that how is it mounted on site. Okay, so that's it. That is the Aerator series. That completes that series as well. It is very easy to select and uh, calculate. Drawings are also there for each and every size, so you don't need to worry. For example, in this is like for 50 HP, so I had a drawing ready. So this drawing I can show you just now. I'll just show you the GA 225 drawing. See, this is the drawing, this is dimensions, everything mentioned. It's pretty much clear. Okay, so no problem in this GA series. This is the Aerator series. That ends the Aerator as well. Now we will go to the king of everything, that is the extruder gearboxes. This is the third and the final catalog of the helical products. Extruder gearboxes are the heart of the industry of plastics and rubber. Mainly plastics, because plastics, anything plastic you want to make, you need to extrude it. Initial plastic is in the form of grains. Okay, so the extruder gearbox is the one which extrudes the uh, helps in extrusion. That is extrusion. What is the meaning of extrusion? Extrusion means converting those grains into a useful form. Okay, by passing through it through a mold. The mold die. The die is basically designed to provide whatever output you want. You want a pipe, you want a wire, you want a what do you call irrigation piping, you want the piping for bigger like a PVC pipe, you want it for some molds, you want it for roto molding, blow molding. There are so many applications. Okay, so that is an extruder gearbox. So let me show you how the operation is done in extrusion. Basically, this is the gearbox here. This is the output of the gearbox. This is the screw. This is the barrel. This is the heating elements of the barrel. This is the motor. This is the feeder from where the grains will fall. This is the die, and this will be the output. Okay. So
this hopper travels by gravity. The rotation of the screw conveys the plastic forward through the heated barrel. Depth decreases, forcing the plastic through a smaller area.
And these heating elements will make
the combination of compression and screw heating.
They do not get cold.
By the time the plastic is conveyed, the plastic is called a melt at this stage.
Which we are doing it, it won't be.
Beyond the screw, there can be a screen pack.
So So the next thing
Pack is a set of wire mesh filters that the plastic must flow through.
it makes it
The screens are typically from 20 to...
becomes a wire or whatever
The screen pack filters can
that's called a breaker
next to the breaker plate, so each screen can support a finer one. Otherwise, the pressure is possibly doing permanent damage to the die.
So what you can see, I can show you is this. This is a video of one Taiwanese company, but it's a beautiful video. I'll show you, it will make you understand what it is. So see, this is a video of a bigger size gearbox of 280 size. Normal electrical gearboxes start 112 model to 250 model, and above 250 is very rare and machines. So this you can see is the piping arrangement and the pump, just to make sure the lubrication is there everywhere. Otherwise, it's a simple construction.
In this program, we'll explain the various types of processing machines used to make the wide range of plastic products in use throughout our lives. A good start is injection molding. Injection molding is used to make plastic parts using two-part molds that, when closed, are injected with melted plastic to form individual parts. Here's how it works. Material gravity flows into the injection machine's screw, where it is melted by the compressing motion of the screw, and then injected into the mold to form the part or parts.
Thrust bearing housing. This is a thrust bearing.
The mold is quickly cooled, letting the parts solidify. The mold opens to release the parts, and the mold closes again to repeat the cycle over and over again. Molding cycles can last anywhere from 1 second for tiny parts, made in tiny molding machines, to minutes for large parts, made in presses the size of a building. Extrusion processes use the same plastic melting operation as injection molding, but there is no mold, and the resin compressing screw rotates constantly, and product is created continuously. Extrusion uses a die, a hollow form that molten plastic is pushed through to create its specific shape and thickness. A water bath or spray chamber then cool the extruded shape and often provide pressure and/or vacuum controls to properly size the product as it passes through. Belts or cleated pullers apply smooth tension on the product and keep it moving in pace with the extruder. A cutter or saw create the final product length, or a winder creates spools of the final product. There are many variations to the extrusion process, but a mixture of extrusion and molding is found in the blow molding process, where plastic is continuously extruded into a tube shape and then clamped in a mold and blown into its shape with compressed air. It's a process that often operates in a shuttle movement with a set of molds. Each mold takes a turn grabbing a section of extruded tube, called a parison, and shuttling it to one side to blow it into a bottle shape, letting it cool, and then releasing it to be filled with product or shipped. Each mold alternates with a second mold doing the same thing for maximum productivity.
It can be vertical, it can be horizontal, whatever you want.
The same blow molding process can also utilize multiple extruders for what is called co-extrusion. Co-extrusion is used to create bottles made up of multiple layers, and each layer possesses special characteristics like suitability for food contact, an outside color for brand awareness, ultraviolet light protection for long shelf life of the product, a layer of regrind for economical reuse of scrap, and many times barrier and adhesive layers are included to separate and bond the layers for a tough, cohesive bottle. A high-volume form of blow molding uses many molds mounted onto a continuously rotating wheel mechanism. The extruder creates a hollow tube, and as the wheel rotates, each of its molds will open, grab a parison from the extruder die, blow the parison into a bottle, allow it to cool, and then place it onto a conveyor, producing a continuous stream of finished bottles originating from that continuous flow of plastic from the extruder. These wheel machines can also produce co-extruded bottles containing layers, the needs of the product, and use reclaimed material for maximum economy and recycling balance. sales of plastic bottles of carbonated beverages has created a unique process for blow-molded bottles made specifically from polyethylene terephthalate, or PET. For PET blow molding, bottles are first created in a test tube shape, injection molded preform, and then, in a separate operation, reheated and blown into their final shape. This two-stage process creates bottles that we, as consumers, know to be thin-walled, yet capable of containing gaseous carbonated beverages without losing pressure or exploding if they are dropped. In the blown film extrusion process, thin plastic material for products like garbage bags or the sheeting used in construction, industry, and packaging are produced. A very thin die opening, which is often fed by multiple extruders, faces upward in a round shape. A tall, thin, continuous bubble is produced vertically by this process, and it's cooled as it flows upward, typically 30 feet or more, where it is then folded and brought back down and placed onto rolls or converted into popular film products. And all these processes, from injection molding to film extrusion, rely on Conair products to support their productivity and efficiency. Thanks for watching.
This is actually...
Not every piece of packaging makes such a spectacular exit.
This is the assembly part.
Millions of packages in Germany simply feel empty at some point, squeezed out and useless. The result is 2.5 million tons of packaging waste each year that ends up in the yellow bag or the yellow bin.
Should match the barrel and the hole should match the
And from there to a sorting plant.
screw die and the bore should
The problem is different kinds of plastic are difficult to separate from each other and from other materials.
This one is used for jacking. So when you want to remove the screw, you just
That's why most waste ends up being used for energy recovery.
here and push. The screw will come out.
The empty packaging is burned for energy in conventional power plants, for example, or in the steel or cement industry. At this sorting plant in southern Hessen, the Milo company plans to greatly increase the proportion of reusable waste, the kind that can be recycled into new products. Waste is collected from yellow bags and yellow bins in the surrounding region. The problem is, the waste contains material that doesn't belong here, like non-returnable packaging and a large amount of other household waste as well.
The output shaft is hollow in this case. It is throughout hollow.
This bottle belongs in the yellow bin. It's made of high-density polyethylene, also known as HDPE, as does this bottle made of polyethylene terephthalate, or PET, and this bottle cap made of polypropylene, or PP for short. These reusable plastics are mixed up with other materials. A homogeneous stream of material gets sorted out later in the process. First, the waste is gathered from a 300-kilometer radius that includes the states of Bavaria, Baden-Württemberg, Rhineland-Pfalz, and Hessen. 120 tons of waste are gathered each year. That equals around 5% of the waste collected in yellow bags and bins across Germany. The sorting takes place almost automatically. In a large machine hall, the flow of waste runs over a 2.5-kilometer long conveyor belt. In the first stage, the material falls into a large rotary sieve. Here, the various packaging and other materials are sorted out according to size. Smaller pieces simply fall through the holes. The rest is transported to 2 additional drums. Finally, 5 separate streams are created containing different sized material. Separating the material by size makes further sorting procedures much easier. In a special air separator, a blast of wind blows lighter material, such as foil, out of the material stream. The air separator and other machines remove most of the foil from the material stream. That makes the hard plastic easier to sort out. The more thoroughly the plastic is sorted out, the better it can later be used to create high-quality products. In a further stage, an infrared scanner quickly scans for types of plastic. Air pressure can then shoot out the PP bottle caps, for example. Then comes the PET, and finally HDPE is sorted out of the material flow.
This shaft is used by using a pulley connection with the motor.
Despite the automated sorting process, the already well-sorted material streams are then picked through by hand.
What is the problem?
The most useful plastics stay on the belt. Around 1/3 of the total initial material, however, consists of mixed plastics and residual waste that has no further use. Everything from old shoes to pieces of wood. It's all destined for energy recovery, incineration. Packaging from the yellow bin is put through more than 30 sorting procedures at the plant in
Here
downtime.
they will keep an 8-inch pulley and here a 12-inch pulley. So
Along with HDPE, PP, and PET waste, there are 4 other plastic fractions here.
1440 into 12.
The sorted plastic is pressed into bales. The HDPE, PP, and PET bales have a purity level of 94 to 98%.
The ratio of the gearbox.
This well-sorted plastic waste is a sought-after secondary raw material in the plastic processing industry. The plant in Hessen supplies companies in Germany and in neighboring countries. HDPE bottles, for example, are used to make pipes or specialized pallets.
Already the motor is a 4-pole, but the final
PP plugs are often turned into flower pots or buckets.
6-pole motor because input speed is reduced to 1000 before coming to the input shaft of the gearbox.
And PET packaging is turned into fibers used in fleece sweaters or into stylish lawn furniture.
Gearboxes are mostly sold from stock. So don't see in this. If it's a 50 HP motor,
but even if the furniture looks great and the sweater is comfortable,
1000 RPM import,
these products only have a limited lifespan within this kind of material recycling.
70, sorry, because
producing these products may save raw materials such as oil, but at some point they too will end up in the dump or waste incineration plant.
And very high safety factor.
Despite all the sorting, a full-fledged material cycle for plastic packaging has not yet been created.
Selection, I'll just brought it down here. GH, that is grooves, helical, extruders.
To create a genuine cycle, that means a bottle is made into another bottle, the sorted plastic fractions need further processing.
Not 20, okay, this is 14. But final RPM is 70 because
System Plastics in Thuringia is doing just that at a special plant in the town of Eisfeld. First, HDPE bottles end up here in a shredder. The resulting plastic shreds are cleaned of any shampoo, yogurt, or any other residue. And a special procedure sorts out the last unwanted remains. The result is a colorful mixture of clean flakes that are made almost entirely out of HDPE. These still have to be sorted out by color. If they were melted down as is, they turn a dirty gray. This color sorting takes place in a special sorter.
standard helical gearbox can
Special
be converted,
mechanics
but this
allow the
cannot
machine
be
to
converted.
isolate single flakes
Always
from a
while
large
ordering
mass.
left, right is to be clarified, the bore is to be clarified, ratio is to be
HDPE
clarified.
particles are run
And
over a slide piece by
99% of the
piece.
time, and every extruder gearbox has
Tens
a
of
cooling coil.
thousands per minute.
Cooling coil arrangement is there to keep
LEDs light up the material stream,
while working, so
while
fan is
sensors
not.
recognize the different colors.
What another thing you need to know,
The data is analyzed by a computer,
always
which controls a panel fitted with more than 60 compressed air
sell
nozzles.
from stock.
A blast of air shoots out the unwanted colors. Only the colorless flakes remain, if so desired. After this process is carried out over the first two slides, it's repeated on the next two. And a final repetition on the last one. The result is an output of 800 kilograms of sorted HDPE flakes per hour with a purity level well above 99%. The material is melted at 220 degrees Celsius in an extruder.
Otherwise, don't submit a general drawing.
The melt is pressed through a filter and once again purified. Then the liquefied plastic is cooled and processed into granules. The result is a high-quality raw material that is put to use nearly everywhere in the plastics industry. Besides HDPE packaging, polypropylene, or PP caps, are put through these elaborate cleaning, sorting, and processing stages as well. Every year, around 20,000 tons of material from the yellow sack is processed here in Eisfeld. But only a small portion gets the full treatment. Production capacity is set to increase in the future, and the procedure is to be further improved. We can already take plastic from the yellow bag and turn it back into plastic. We now plan to enter areas related to the food industry. We'll start with cosmetics, then move on to food at some point. We think it'll take a few years, and then our plastic will be hygienic enough for that.
Normally we don't go for EP unless
Recycled material from Eisfeld is already sought after by the makers of washing and cleaning products. At its location in Mainz, the Vanna and Matz company produces more than 130,000 tons of foamy and fragrant detergents. Normally, the packaging ends up in the yellow bag. To complete the material cycle, the company tries to use as much plastic as possible from the yellow bag to produce its bottles. The HDPE granulate from Eisfeld is fed here into a machine. It's then melted in a special extruder. The bottles are formed under air pressure. Afterwards, excess material is trimmed off and the bottles are ready. Even though these bottles were made using only recycled plastic from the yellow bag, any standard production facility could manufacture them. Finally, the HDPE bottles are filled up as usual and delivered to shops. 5.5 million bottles each year. It's not only HDPE bottles that are made of recyclable material. These PP caps are also produced using 100% plastic from the yellow bag. Once again, it's recycled granulate from Eisfeld that does the job. We use recycled material from the yellow bag for our PET and HDPE bottles and for our PP caps, and we hope to increase this share in the future. We're still looking for market partners in this initiative in order to further lower recycling material costs. In other words, the more packaging producers use recycled material from the yellow bag, the greater the production capacity will grow, making it more economical to use this recycled material. At Vanna and Metz, PET bottles make up a large share of packaging. Despite all the sorting with high-tech machinery, adequate quantities of PET granulate from the yellow bag still aren't available. So PET granulate from the yellow bag is mixed with PET granulate from the deposit system, mostly made from empty beverage bottles. The preforms from the first production stage in mice are blown into bottles and later filled. In the end, they're made of 20% PET plastic from the yellow bag and 80% plastic from the deposit system. More than 80 million bottles are produced this way each year at the plant in Mainz. The company aims to gradually increase the share of PET bottles made with yellow bag material, while at the same